Now we're going to look at how to solve absolute value equations when there are two absolute value symbols. And here you see we have the absolute value of x plus 8 equals the absolute value of 2x plus 1. When you have absolute value symbols on both sides of the equal sign, there's a couple of things that could happen. Let's say I have the absolute value of 4 equals the absolute value of 4. Those could both be the same thing, right? 4 equals 4. Same thing if I had the absolute value of negative 4 equals the absolute value of negative 4. Those are both the same thing. They're both equivalent. But they can also be opposite. If I had the absolute value of 4, that is equivalent or equal to the absolute value of negative 4. They're both equal. So the things in the absolute value symbols can be the same or they can be opposite. So just like before, we have two things to solve. So we're going to take that x plus 8 out of the absolute value symbols and we're going to set it equal to the absolute value of 2x plus 1. That's one equation we can solve. The other equation we could solve, because we see right here that they can be the same, so we set them equal to the same, or they can be opposite. So the second thing we're going to do is take the first one out as is, but we're going to set it equal to the opposite of the second one. So we're going to put a negative sign in front of it and parentheses around it. That's important. So these are now the two equations we're going to solve. Notice we have a variable on both sides. So if I have x plus 8 equals 2x plus 1, I'm going to subtract x from both sides. And I get 8 equals, that's an 8, equals 2x minus x is x, plus 1. Now I'm going to subtract 1 from both sides, and I get x is 7. That's my first possible solution. Now the second one I'm going to solve, x plus 8 equals the opposite of 2x plus 1. I'm going to copy the x plus 8. Remember that a minus sign outside parentheses, that's a negative 1. So I'm going to distribute the negative 1. Negative 1 times 2x is negative 2x. Negative 1 times 1 is minus 1. Now I have x plus 8 equals negative 2x plus 1. That negative 2x has the smaller coefficient, so I'm going to add 2x to both sides. X plus 2x is 3x. 3x plus 8 equals negative 1. Don't lose that minus sign. Now it's a two-step equation. I'm going to subtract 8 from both sides. 3x equals negative 9. Divide both sides by 3, and x is negative 3. So my two possible equations are x is 7, not equations, solutions are x is 7 and x is negative 3. So I'm going to plug these in and see if they work. If I plug in 7 for x and I get 7 plus 8, does that equal the absolute value of 7 plus 8? Does that equal the absolute value of 2 times 7 plus 1? So this would be the absolute value of 15 equals the absolute value of 2 times 7 is 14. 14 plus 1 is 15. Does the absolute value of 15 equal the absolute value of 15? Yes, so that one works. Now let's check it with negative 3. Does the absolute value of negative 3 plus 8 equal the absolute value of 2 times negative 3 plus 1? So negative 3 plus 8, this would be the absolute value of 5. And I don't know why I wrote an 8 there. The absolute value of 5, does that equal? Well, 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Does the absolute value of 5 equal the absolute value of negative 5? The absolute value of 5 is 5. The absolute value of negative 5 is 5. So that is also equal. So my two solutions, I found two solutions here like we typically do with absolute value equations. They are 7 and negative 3. We have seen before that sometimes when you've got variables on both sides of the equal sign, and now that we've got variables and absolute value symbols on both sides of the equal sign, some weird things happen. Sometimes we get things that we think are solutions, but they don't satisfy the original equation, and those are called extraneous solutions. See that word extra in there? They are extraneous solutions. That means they look like an answer. We got them as an answer, but they don't work. And you have to do this when you have a variable or an absolute value on both sides. Okay, that's when you have to check for extraneous solutions. So this time, look, I only have the absolute value on one side of the equal sign, but I'm going to set it up the same way. The absolute value of 2x plus 12 equals 4x. So I take that 2x plus 12 and I set it equal to the 4x. And then for my second equation, I take the 2x plus 12 and I set it equal to the opposite of 4x. So I have to set it to what's there and the opposite of what's there. So this is two equations. 2x plus 12 equals 4x. I'm going to subtract 2x from both sides. I get 12 equals 2x. I'm going to divide both sides by 2, and x is 6. So that's a possible solution. On the next one, since that negative 4x is over there all by itself, I'm going to move the 2x again. I'm going to subtract 2x from both sides. I just have to watch my signs. So I get 12 equals negative 6x. I'm going to divide both sides by negative 6, and x is negative 2. Now I need to check these in my original equation. So I'm going to substitute x is 6. So I'm going to check, is the absolute value of 2 times 6 plus 12, does that equal 4 times x is 6? So what do I get? 2 times 6 is 12. 12 plus 12 is 12. I'm sorry, 12 plus 12 is 24. So that's the absolute value of 24. Over on the other side, 4 times 6 is 24. Does the absolute value of 24 equal 24? Yes. So 6 is a solution. Now let's check the negative 2. So I'm going to check the absolute value of 2 times negative 2 plus 12. Does that equal 4 times negative 2? So 2 times negative 2 is negative 4. So this is going to be the absolute value of negative 4 plus 12. And 4 times negative 2 is negative 8. Notice, is the absolute value of something ever going to be a negative number? So negative 4 plus 12. Does the absolute value of 8 equal negative 8? No. So negative 2 does not satisfy the original equation, so it is an extraneous solution. My only solution is 6. This time I have the absolute value of x plus 5 equals the absolute value of x plus 11. So remember, when I have this weird stuff going on with absolute value on both sides, my two equations, I take the first one directly out of the absolute value symbol, so x plus 5 equals, and I set it equal to x plus 11. And then my second equation, I take the x plus 5 and I set it equal to the opposite of x plus 11. So I do the minus sign in the parentheses. That's important. So look at x plus 5 equals x plus 11. Notice I have the same thing on both sides, an x. Can I add 5 to x and then add 11 to x and these stay equal? No. So I know this is no solution. You can say that right now, or you can subtract the x from both sides. The x's go away and you get 5 equal 11, which is not true, so this is no solution. So I had one of my equations that doesn't work at all. Now I'm going to do the x plus 5. I'm going to distribute this negative 1. Negative 1 times x is negative x. Negative 1 times 11 is negative 11. Now, x and negative x are not the same thing, so I have to solve this. So I'm going to add x to both sides. X plus x is 2x plus 5 equals negative x plus x becomes 0. Those were inverse operations. Bring down the negative 11. Now it's a two-step equation. I get 2x equals negative 16. Divide both sides by 2, and x is negative 8. Now, one of my equations didn't even give me an answer, but I do need to check my second solution and see if it works. So I'm going to take -8 and I'm going to plug it in. Does the absolute value of -8 plus 5 equal the absolute value of -8 plus 11? So -8 plus 5 is -3. Does the absolute value of -3 equal the absolute value of -8 plus 11 is +3? Does the absolute value of -3 equal the absolute value of +3? Well, those are both 3, so that's true. So my solution, the one that made the equation true, is -8. So this one had one solution of -8. Okay, you're going to try these two. First one is the absolute value of x plus 6 equals 2x. I'm going to stop the video. I want you to set up your two equations and check that your two equations are correct before you solve them. You should have x plus 6 equals 2x and x plus 6 equals -2x. Now I want you to solve these two equations and tell me what your two potential solutions are. So our two potential solutions are 6 and -2. If you didn't get that, correct your work. Make sure you understand what you did incorrectly. Now, I want you to check both of those equations and tell me what your actual solutions are. So, x equals 6, when I plugged that in, that made a true statement, so it is a solution. X equals -2, when I substituted that back into the original equation, it made a false statement, so it does not satisfy the original equation. It is an extraneous solution, and my only solution is 6. The next one is the absolute value of 5x minus 2 equals the absolute value of 5x plus 4. Write down the two equations that you're going to use to solve this absolute value equation. So the two equations that you should have are 5x minus 2 equals 5x plus 4, and 5x minus 2 equals the opposite of 5x plus 4. Make sure you have that minus sign in the parentheses. So those are your two equations. Now solve them and see what your two potential solutions are. The first equation has no solution. You can get it down to the -2 equals 4 and tell me there, or you could see from the very beginning, 5x minus 2 can't equal 5x plus 4. That's no solution. The second one, and I ran out of room here, so this is kind of messy, but the second one I ended up with x equals -1/5. So follow that through, make sure your solution looks like this and that you got the same answer. Okay, now I want you to check and make sure that -1/5 works. So plug -1/5 into the original equation and see if it makes it true. I plugged it back in. 5 times -1/5 minus 2 in absolute value symbols. And I'm trying to see if that equals the absolute value of 5 times -1/5 times 4, or plus 4. 5 times -1/5 is -1. -1 minus 2 is -3, and the absolute value of -3 is 3. 5 times -1/5 is -1. -1 plus 4 is 3, and the absolute value of 3 is 3. So -1/5 works, and that is the only solution to this equation.